Chem 107 students, welcome to Chapter 3 on fossil fuels. So we're going to talk about energy in this chapter. Most modern fuels, so ways we get our energy, are things we burn. Burning is called combustion in chemistry. That's the type of reaction burning is, combustion. Things we burn involve coal, oil, natural gas, propane, wood, and gasoline. These fuels, however, are not renewable, not any of them. They also produce a lot of pollution, as we learned in Chapter 1, and they produce greenhouse gases, which is a big problem that we're going to talk about in Chapter 4. The rate at which we're burning these fuels is not sustainable. We're going to run through them in just decades to a century, and it took them millions of years to form. So we're going to use them up much faster, much faster than we can replace them. So not sustainable at all. So fossil fuels are three of the most important things we burn. And there's three of them, and they are coal, petroleum, oil, and natural gas. Now, up until about 1880, the main fuel source was wood. We burned a lot of wood, trees. Then coal became number one in 1880, and it was number one until about 1950. At 1950, we had the oil boom. Oil has been number one since 1950. So fossil fuels, again, coal, oil, and natural gas, how are they made? Well, green plants, millions of years ago, captured the sun's energy via photosynthesis. They produce glucose and oxygen gas. When they die, they decompose partially and they get buried under dirt. And as time goes on, temperature and pressure pushes down on them and they start to cook and decompose into coal and oil and natural gas. However, this process to make fossil fuels takes hundreds of millions of years. So it's not like we can go plant some coal in our backyard. I'm not going to go and just have some oil come from a basket that I make. So these things take millions of years to produce, and yet we're going to use them up in just a couple of centuries. The bottom reaction there is showing you how plants take in CO2 and water, H2O, and produce glucose, C6H12O6, and oxygen gas, O2. So that's the reaction there. All right, so you need to remember how fossil fuels are made. Definitely remember that. Also remember the three fossil fuels. Energy usage. The United States is the top energy consumer per person for a country. We're number one in a place where we don't want to be number one. Canada is a close second, however. The United States is very casual about our energy usage. I mean, yeah, you say turn off the lights when you leave a room, but for most of us, it's not that big a deal. Now, in Arizona, we're perhaps a little bit more careful with our air conditioning. Most people don't leave it on 70. The air conditioning bill would be too high, and you'd probably break your air conditioner. But other than the air conditioning, we're pretty cavalier about our energy usage. We plug in our cell phones, we plug in things and charge them. We have things plugged in all over the house. We don't unplug them when they're not in use. So we could do a lot better. About 80% of the United States energy comes from fossil fuels, coal, oil, and natural gas. Burning them releases CO2. PM, we should know what PM is. CO, we should know what that is, CO, NOx, and SOx, which we're going to call NOx and SOx. So why are these gases a problem? Well, CO2 we haven't learned about yet, but we're going to learn that it's a greenhouse gas in Chapter 4. PM stands for what? Particulate matter, little particles in the air, soot, smoke, fog, little things floating around in the air that are a pollutant. CO, carbon monoxide, a main pollutant. NOx and SOx, main pollutants. Also, burning coal at least produces mercury in the ash left behind. And then we go dump that into rivers, we drink it, and we get mercury poisoning. So mercury is also a problem left over in the ash from burning fossil fuels. So a little bit more about NOx and SOx. What does the X mean? Well, it's just a shorthand way to write. NOx stands for NO and NO2. So in other words, X can be a 1 or a 2 for NOx. SOx, SOX, that stands for SO2 and SO3. So for SOx, X is a 2 or a 3. So you need to remember that. These are main pollutants. They're also gases that cause acid rain. Now, the media, because they're usually not very scientifically literate, refers to them as NOx and SOx. And we don't mean knock like knock on wood. And we don't mean socks like socks on your feet. Okay, so NOx and SOx are chemicals. NO and NO2 and SO2 and SO3. So remember what NOx and SOx stand for. So here's just an example of one source of how the United States spent their energy in 2017. So petroleum oil was 37%, natural gas was about 29%. That may be estimated a little high. Coal is 14%, nuclear power 9%, renewable energy 11%. So what we need to be more sustainable is for those fossil fuel pieces of pie to decrease and the renewable energy piece of pie to get bigger. So that's what we need. All right, the first law of thermodynamics. You need to remember this. Energy cannot be created nor destroyed, only converted from one form to another. Remember that. First law of thermodynamics. The forms of energy can be chemical energy, electrical, nuclear, mechanical, radiation, heat, friction, and sound. All of those are forms of energy. For example, if I hold a book up high, it has potential energy. If I drop it, it falls down and has kinetic energy, energy of motion. When it hits the floor, it converts to a little bit of heat, friction, and sound when it lands. So I can convert energy forms, but I can't create energy from nothing. And I can't destroy energy either. Now, chemical energy is energy that is stored in chemical bonds, bonds that hold atoms together. Chemical reactions like combustion release this energy. And that's why it's a fuel source, because we have chemical energy stored in the bonds of our fossil fuel. And when we burn the fossil fuels, we release the energy that was stored in the bonds. So let's talk a little bit about the first fossil fuel, coal. It is a solid. So coal is the solid fossil fuel. Ugh, that picture. Wouldn't want to be breathing right there, would you? So coal is made up largely of carbon atoms with some hydrogen, oxygen, nitrogen, and sulfur atoms. 85% is carbon. A typical coal power plant uses 1.5 million tons of coal per year. The formula for coal is roughly C135 H96O9 N1S1. There's also traces of mercury, arsenic, and lead in coal. So coal, you need to remember, is largely made up of carbon. You need to remember that. And that it's a solid. The coal power plant. So power plants use chemical energy stored in the fossil fuels that we burn, combustion, and then we release the energy stored in their bonds. To convert the chemical energy into heat, and then we take that and turn it into kinetic energy and then electrical energy as the end result, because we want to get energy to our houses so we can plug things in. Burning coal does create heat, so it turns into heat energy, which boils water. We boil this water and turn it into steam, a gas, and it flows along pipes, and it goes past some turbines which spin. When the turbines spin in a magnetic field, that generates electricity in wires, and then we can push that electricity through wires to our homes. Once the steam goes by the turbines, it can be condensed back into liquid water, which flows back into the furnace to be boiled again. It's a loop of water. Combustion of coal converts potential energy to heat, boiling water, which turns into mechanical energy, turning the turbines, which converts into electrical energy, which comes to our home, and then it runs our appliances and charges our phone. So coal power plants are only between 35 and 50% efficient. So we lose a lot of energy. The energy is lost each step along the way. A lot of it is lost as friction and heat. Car engines are even worse. Car engines are only about 15% efficient. That's awful. So gasoline powered cars, that is, are only 15% efficient. Terrible waste of energy. So here's the picture that goes along with what I just said. We have our coal coming into the power plant. We take it into the boiler room, the furnace. We burn the coal. We have the water loop going through there, so the water gets heated up into steam. Steam then goes out the top of the furnace room into where the turbines are. See the little turbines? Steam passes by them, it turns them, they spin, create the electricity, which comes out in these yellow lines, the transmission lines to the transformer. Then the steam continues to go down to the condenser. See the condenser? And it turns back into liquid water. And the liquid water goes back into the boiler room and starts the cycle again. Now, there is a second loop of water in this picture from the river. The river brings in cold water and helps cool everything down to condense the first loop of water back down to liquid. And then the river water flows back out. So we just take some river water in and back out. It comes out a little bit hot. So the river does get some hot water. It's called thermal pollution. And usually around that area, nothing's living. So it does pollute the river. But that's basically how the coal power plant works. So, problems with coal. Mining is dangerous. I know China had 4,700 deaths in 2006 alone. It's really hard to get accurate data on that, though, for every year. There are accidents in mines all the time, and miners get sick being in the coal mines. They get black lung disease. Mining also ruins the environment. Erosion occurs because we don't replant the trees and the plants, so erosion occurs and it just turns into an ugly, ugly dirt area. The groundwater gets exposed to the mines, and it becomes acidified and high in iron and aluminum, which is bad for fish and the humans that eat the fish. Coal is dirty. It makes soot, it makes NOx, it makes SOx, it makes particulate matter. Also, coal blackens buildings and churches and statues. Costs money to go and clean these things up. Often near coal power plants, you can see scaffolding up against the buildings where people are literally washing the buildings off. They're washing the soot off the buildings so they're not black. Coal also has mercury concentrates in the ash. We've talked about that. It lowers IQ. Not a good thing. Coal also produces CO2, a greenhouse gas, GHG, greenhouse gas. Coal accounts for about 40% of our global CO2 emissions, so it's a huge player in climate change. Also, we have to take that coal to the coal plants. 1.5 million tons. So there's a lot of transportation going on, transporting the coal on trucks or trains to get it to the mines. And transportation burns gasoline and has lots of tires get used, and rubber tires are all over the highway, and pollution from the trucks and the trains. So there's a lot of problems with coal. You should know some of them in case I ask you to name 2 or 3 problems with coal. Coal mining is tough, causes black lung. There's a coal miner, there's some black lungs. Not pretty. So why do we use coal? It's cheap. And the United States actually has plenty of coal. 25% of the world's coal is here. A lot of it in the Appalachian Mountains back east. Have you ever heard of clean coal? You don't hear about that so much anymore because it was very misleading. It was a made-up term and it wasn't clean. So people don't really say it anymore because it was disproved. But when people talked about clean coal, it really had nothing to do with the coal. It meant they put scrubbers on the coal plant stacks so that when the pollutants come up the stacks, it would remove some of them from the smokestacks. like filters. Well, we should do this to all our coal plants. All our coal plants should have filters at the top of the smokestacks. So it had nothing to do with the coal. There's no better clean coal. It's the same old dirty, nasty coal. And none of this addresses CO2 emissions anyway, because the filters can't filter out CO2, the greenhouse gas. So people don't really talk about clean coal anymore because there wasn't any new coal and it was just kind of misleading. So you don't really hear about that much anymore. All right, so that's our talk about coal. We'll end this first video here. I know that took a while. Next video, we will talk about oil. See you later, 107.